Okay, the last three questions then from this national test. We have a square area and there are no dimensions to this square at all, and we are supposed to calculate what is the fraction of the shaded area compared with the whole area. Well, because we don't know the dimensions, and we could measure it with a ruler, and you'll find that the length of the inner square is 3 centimetres. But the length of the outer square is not 4 centimetres, it's actually 3.8. So you can't actually use that. Instead, we just need to think about how many whole squares do we have inside the other square. So there are two ways of doing this. One is to work out the area of the outer square, which would be that we have 4 times 4, which is 16 area units of the outer square. So the outer square has 16 area units, and then we have 4 small triangles here that are all 3 centimetres long and 1 centimetre wide. And the area of one triangle, one outer triangle, is 3 centimetres by 1 centimetre, the length times the height, the breadth, divided by, and it's a perpendicular height, so that's all right that we use this, the length times the perpendicular height divided by 2. So that's 1.5 area units. But we actually have 4 of these triangles, 1, 2, 3, 4. So the area of all 4 triangles, we'll just put the symbol there for triangle, is 6 area units. So the shaded triangle in the middle will be 16 minus the area of the outer triangles, all divided by the 16. So the fraction of the inner square will be the inner square divided by the outer square. So we get 10 sixteenths. We wouldn't leave this as 10 sixteenths because we can divide top and bottom here by 2 to give us 5/8. That's one way of doing it. Another way is actually looking at the inner square by itself and thinking, okay, here we have one whole square, and here we have another whole square, and here we have 3, and here we have 4. So here we have 4 whole squares in the middle, plus 4 triangles. How many triangles, what's the area of this triangle here if we actually look here, if we take this triangle from here to here to here. We have the area of one of the triangles, one of the outer square, we'll call them the inner triangles because these ones are inside the other ones. The area of an inner triangle is the same, the length times the breadth times the perpendicular height divided by 2, which would be 3 times 1 divided by 2. So again, it's 1.5 unit areas. So we know that there are how many of these triangles around that are shaded? Well, there's one here, one here, one here, one here, and the final one is here. So we actually have 4 of these shaded triangles as well. So we would have 4 whole squares plus the 4 shaded triangles, which would be 1.5 times 4, because 1.5 was the area of one of the triangles. That would be 4 plus 6, which equals 10 unit areas. So we can see with either method that we get that the area of the inner square is 10 unit areas, divided by the total, which is 16 unit areas. We'll get the same fraction no matter which method we choose, 10 sixteenths, which is the same as 5/8. So the fraction of shaded in this figure is 5/8 or 10 sixteenths. Or you could actually have worked that out as a decimal, but because this is the non-calculator paper, you don't need to. Okay, then we had this question here about simplifying the expression. And here we have a plus 2a plus 3a. All of these top terms are in terms of a, so we have to actually add them first. We can't cancel anything down here. A plus 2a plus 3a would be the same as 6 lots of a. A is the same as 1 lot of a, so 1 plus 2 plus 3 is 6 lots of a, all divided by a. Once we've actually added all our top terms, we can cancel a with itself, giving us the final answer, 6. I did notice when I was looking at some of your papers that some of you had actually tried to do like this, and let me explain why you can't do that in maths. You're so used to it being, oh, you've got a up there and you've got an a down there, so let's cancel this a with that a, giving you 2a plus 3a left, which is 5a. You can't do that because a plus 2a plus 3a divided by a does not mean a divided by a. It means it's a divided by a plus 2 lots of a divided by a plus 3 lots of a divided by a. So this a down here has to divide into the a term, the 2a term and the 3a term. Now you can cancel this a with this a with this a, and this a with this a, because they're all in the same divide sign here. A divided by a would be 1. 2 divided by 1 would be 2. 3 divided by 1 would be 3. 1 plus 2 plus 3 is 6. So if you do this correctly and actually rearrange that to a divided by a, 2a divided by a, and 3a divided by a, you actually end up with the right answer. But you can't cancel one a against one of the a's, because that is not what this expression means. It means this, that you've just added all the terms up on the top there and you've got the same denominator on each one. So you have to simplify the terms either this way or this way to get the right answer. And don't mix it up with one word. What are we doing when we have 6a squared divided by 3a then? Now that's different. There's no plus signs here on the top or on the bottom. So we can think of 6a squared as being 6a times a divided by 3 times a. Here we can cancel one of the a's because we're using only multiply and divide. There are no addition and subtraction signs. 1a will cancel against 1a here. 6 divides by 3's going to 6 2 times, so we get the answer here, 2a. So 6a squared divided by 3a, that can be simplified to 2a. Here you were allowed to cancel an a there, but only because it was multiplied. So don't mix these terms together. Okay, then we have this last one where we have x with divided by 0.1. Well, we don't want to know what x divided by 0.1 is, so let's make it a little bit simpler for ourselves. Let's multiply the whole of this side by 0.1 and multiply the whole of this side by 0.1 as well. Then we get that 0.1, we could actually take this outside of the front of the brackets as well. So we take our 0.1, we put 0.1 here. 0.1 times 1 is the same as 0.1, so this is actually the same thing here. We now have 0.1 divided by 0.1, which cancels. We have x minus 0.2 equals 0.1. Move the 0.2 to the other side, it becomes plus 0.2. So x equals 0.1 plus 0.2, which equals 0.3. Another way of doing this one, which I think is a little bit easier, is if we rewrite that again. X minus, what was it, 0.2, all divided by 0.1 equals 1. Is that I've told you that what you can do to move anything that's divided on one side of the equal sign, when it goes to the other side of the equal sign, it becomes multiply. So we can rearrange this to x minus 0.2 equals 1 times 0.1. The divided by here becomes multiply on the other side. So we then get that x minus 0.2 equals 0.1. When we move the minus 0.2 to the other side of the equal sign, it becomes plus 0.2. So we get equals 0.1 plus 0.2 equals 0.3. So you have to practice manipulating with algebra, understanding when you can cancel and when you can't cancel. If there's minus signs involved, you can't do any cancelling, and yes, you cancel everything. But you can, when you've just got one term down here, divide by 0.1, move it to the other side and give it a multiply 0.1. And yeah, good luck with those.